All right, everyone, how are we all doing tonight? This is Alex Juhan, and this is another video in my cybersecurity series. So today we are going to be discussing a problem that one of my colleagues is working on. And essentially, they were given this problem up here, and you can also see it here. They were given the modulus n, and using that modulus, there were 8 ASCII characters encrypted. Now, for those of you who don't know, ASCII characters follow a format where A equals 65, B equals 66, all the way to Z equals 90. Now we have these encrypted ASCII characters, numbers, and we want to decrypt them back to their values of 65 to 90, whatever they are, to decode the message. The only other information given is that the private exponent is D equals 8743. Now, this problem is actually representative of Euler's theorem, which is really important for the RSA crypto system. And this theorem is widely used in internet communications. But now that we have this information, all we need is N and D. Using that, we can decode everything. I did this in Python because it does all the math for me and makes it much simpler. So to start, if we didn't have N and they gave us something like P or Q, we could figure it out that way. But essentially, the N value, the modulus, is always the value of P times Q. And P and Q are always prime factors. So in this case, it's 101 and 103. Multiply them to get 10,403. All right. Next, D is going to be the decryption exponent, and I can show you where we're going to plug that in our problem later. If we really needed to, we could calculate this, but we already have N, so we're okay. Now this, I created a variable to represent each number in the list, so we'll start with 7427. Okay. Now, we created the variable M here to represent the decrypted number. And we can see the formula. It's going to be the cipher number, in this case 7,427. Now these two asterisks in Python are actually the notation for exponent. In Python, the caret operator is actually used to invoke an exclusive OR operation. It's not super important for this video, but so we are doing the cipher value, in this case 7,427, to the power of D, which in this case is 8,743. Okay, then we're going to do mod, which is represented by the percentage symbol, and then the value of N, which we were given earlier. Okay, in my code, we're going to print M just so we can see what that value is. And then I'm going to create another variable called decrypted. And this character function essentially converts the value that this M is going to be equal after this problem goes through, and it is going to convert the number into a letter character. So if some of you actually have this assignment, I'm not going to solve the full thing because I don't want to do your homework for you, and I want you to practice this yourself. This is a great exercise you can do in Python yourself, but essentially I'll test it real quick. Cool. So the value of M after decoding it was 71, which translates to G. So the first letter in this encrypted message is G. Okay, so I'm not going to do any more letters. If you'd like, you can absolutely test this problem out. Test this code out yourself. I'll have it on my GitHub and a link to it below. But an even better practice is to open up VS Code yourself, go through this video, try to add all of it yourself so that you can get used to working in Python, creating variables, etc., and then running the script yourself. And once you've created this, you can just go through each number in the list and then decode it that way. There are plenty of more complicated Python functions and features I could have done. I could have created an array and iterated through it to do it that way, but this is just a simple Python code I made in probably like 1 minute just to demonstrate how this problem works. All right, so I think that's going to be it for today. If you are interested in more content like this, please like and subscribe. It would really help me out. And I'll be releasing at least one video a week, hopefully more, on various topics. If there's anything you'd like me to talk about, please let me know in the comments below. I really appreciate you staying around, watching the video, and all the support. So I'll see you next time. Thank you.